Okay, so today we're solving log equations. This is just a little bit of practice I want you to try. I'll give you a few seconds while I pause. All right, on that first one, you should have written the 49 as a 7. That way this and this will have the same base. So log base 7 of 7 squared is how I'd write 49. And I'd also, instead of using that funky looking cubed root, I'd put a 1/3 like this. Then you probably would have noticed that that's the same as log base 7 of 7 to the 2/3. And then if these two match, then that one is the answer. Raise your hand if you had that right. Good. On to the next one. This one is not in base 10, therefore your calculator can't do it unless you know how to put it in like log base 10 of 36. We don't even need to say the base 10 because that's the only one your calculator can do, over log 4. Unless you've got the new operating system. That's true. The new operating system will allow you to do multiple bases. All right, so log 36 over log 4 comes out to 2 point something. I can't remember. Who's got this one? Raise your hand if you've already got this answer. Decimal. All right, in the back. 2.5 something anyways. All right, good. Probably rounds to 2.6. All right, now on to the next one. This one I would say is 2 times x plus 1 to the power of 1/4 plus 7 equals 11. Then you subtract 7 from both sides and you get 4 on the right hand side. Then you divide by 2 and you get 2. I've done 2-ing 2 steps at once, which is dangerous. And then you're going to put both sides to the what power? 4th power. 2 to the 4th is 16, so I have x plus 1 equals 16, and that means x equals 15. Raise your hand if you had that one right. Good. All right. That's just a little review. Now, let's just break down for a second. When you look at this, right away you should think, don't leave this like this. At the minimum, write it as log base 7 of 49 to the 1/3. Use your fractional exponents. Next, always look for common bases if you can. So this one we already did, log base 7 of 7 squared to the 1/3. The key though is look for common bases. Use those properties. All right, so let's use those properties. Do you see some common bases in that first one? So what's the answer? 6. That's it, because that and that are the same. Let's go to this one. Doesn't have common bases now, but do it quick in your head. Make them common bases. What'd you get? 12. Because log base 7 of 7 squared to the 6th means these are the same, and now that's the answer. 2 times 6 is 12. All right, this one, these are the same, so that's the answer. True or false? True. The answer is 46. You could set that up and say equals x if you want to reason it out, and then you just have to remember that you can write any exponential like this base to that exponent. So I'd probably write this as log base 12 of, and it always goes over here, x is equal to, and then it always goes over here, log base 12 of 46. Do you see how that proves that x must be 46? You see how that works? Okay. But otherwise, you can just know what the property says and say, oh, if these two are the same, the answer's got to be there. All right. This one, if you're going to put it in the calculator, what would you do? Log 7? Log 3? If this had been like 8 and 4, could we have canceled those? No, we could not. This is not a multiplication right there. So therefore, don't look to try to cancel logs on top of each other like that. Like that log 8 over log 4 could not reduce to log 2. It would not work. All right. Now, let's talk about solving simple logarithmic equations, which is the topic for today. The main point here is that sometimes you have a variable inside your log equation, and you want to solve for that variable. Well, you don't need any new information to do this. You just have to know how logs work. the variable is either going to be in this spot. What's that spot called again? The base. Or it's going to be in that spot, which is called the argument. And how about that spot? What's that spot's called? Well, in my notes it says somewhere opposite the log, but basically I like to call that the answer or the solution. Okay, so it's in one of these three spots. It's got to be either the argument or the base or the answer. And so we're going to be focusing today on the ones that are in the base. So it's going to have the x down here in the base. And so all you have to be able to do is write a log like this in this kind of notation. What's that notation called again? Exponential. And once you've written in an exponential, then you just have to solve it from there and it'll be a piece of cake. All right. So this one right here is got my base to that power equals that answer. Once you write that out, and see if you can solve this one yourself. X minus 4 to the 3 halves. Notice I put it in parentheses. Equals 64. Okay, so we're going to start by putting them to the 2/3 power. Now, without a calculator, you're stuck with figuring this out in your head. I'd break it in two parts. You want to tell me which parts? To the 1/3 to the 2. Okay. What is 64 to the 1/3? 4. 4 times 4 times 4 makes 64. 4 squared then? 16. So it's really x minus 4 equals 16. Then you add 4 to both sides. X equals 20. Raise your hand if you had that one right. Good. Moving on. This is just another simple one. Follow that little circle of life. This to this equals that. Write your exponential. Solve it. That'll be a piece of cake. You'll need a calculator for this one though. Okay, so you start by writing the equation out in exponential form, then you put it to the 1/3 power, and you end up trying to do 11 to the 1/3 in your head would be about impossible. So take the calculator. Don't forget, if you don't have that new operating system, you probably have to put in parentheses 11 to the power of parentheses 1/3. And what did you get? Raise your hand if you had 2.22. All right, good. This one is very similar. It's just got a little complication in that this is a little bit bigger. Okay, try that one all by yourself. See if you can handle this without me. Okay, so I'm going to start with 3x plus 1. I'm going to put it to the 5th power. And then I'm going to put that equal to 239. Then I have to take the 5th root of both sides. I'll have 3x plus 1 equals 239 to the 1/5. What's that? 2.99. I'm going to round that to about 3. That's okay. You don't have to have rounded it. Your answer will come out really close to mine. X equals 2/3. If you have a decimal, wouldn't that be about 0.666? 0.6 repeating? So if you're really close to that on decimal, you're probably the same thing as me. Raise your hand if you had that one right. Good. All right, so you basically just, if you know how to set up exponential, if there's only one thing you remember out of logs, if you can remember how to take a log and turn it into an exponential like this, the circle of life thing, if you can do that, that's the biggest thing you use over and over and over again. Yeah, I got to use other things too, but if you don't know that one, you're really lost on logs. Okay, so you got to be able to make an exponential form. All right, rapid fire. What's the equation for this one? X to the 3rd equals 64. That's really easy to solve then, right? Put both sides to the 1/3. Okay, this one, x to the equals 5 halves. Then I got to put both sides to the squared, squaring both sides. X equals, what? 25/4. Okay, this next one, that's a little more complicated. 4x plus 3 to the 5/4 equals 32. This one can be done in your head because you can do 4/5 to both sides. The 1/5 root of 32 is a nice number. It's 2. And then you do 2 to the 4th is 16. All of a sudden it's just 4x plus 3 equals 16. Easy to solve from there. That's all there is to it.